if we're given a data set that has two quantitative variables, then our analysis procedure can actually be enhanced. So we can do the univariate analysis, box plots, histograms, descriptive statistics, yada, 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 but we can actually compare the two things directly if it makes sense. When we do that comparison of two quantitative variables or just two variables in general, it's called bivariate analysis. Bi meaning two. So two variable analysis. Okay. Now imagine we're working with two quantitative variables. Okay. And we want to create a visualization. Okay. And consequently, because we have two variables, we will have two axes. Okay. And we're going to place the explanatory variable or kind of the independent variable along the horizontal axis and the response variable or dependent variable along the vertical axis. So I have some examples here. Okay. 4 of them. Okay, so I'm just going to kind of draw a sketch here. And I'm only using the first quadrant if you're thinking about the mathematical interpretations of these grids. And I want you to imagine you need to make a visualization of these. So which axis in the upper left here would amount of caffeine consumed go on versus number of worked go on, okay? Yada, yada, yada. And go through and see if you can identify which one is the explanatory variable, which one's the response variable, and then label the graphs appropriately. Resume the video when you're ready to see my responses. Here are mine. So in the upper left, I put caffeine on the horizontal axis, meaning that the amount of caffeine would influence the number of work items you complete, or put differently, the number of work items you complete depends on the amount of caffeine that's consumed. And I would conjecture that the more caffeine, perhaps, that you have, the more work items you could complete. So if I were to think about what the data would look like, I might expect something like this. Okay? And this next one, actually the next two, are kind of interesting. So the amount of time spent on vacation versus the amount of money in your bank account, it was a little unclear for me which one would be the explanatory and response variable. So in one line I saw, well, if you spend a lot of time, or I guess if you have a lot of time on vacation, that means your bank account is going to be influenced because you're going to have less money in your bank account, right? So amount of money is dependent on the amount of time you spend, and conversely, the amount of time is also dependent on the amount in your bank account. So it was unclear to me which one would be on the horizontal and vertical axes. Okay, so either one would actually be correct, and we might actually need to dig deeper into the context. Same thing with height and weight. You might imagine, weight is influenced by height, but that's not always true. So does weight influence height or does height influence weight? That's unclear. We would need to dig deeper into the data. And the last one, this one was a little bit more clear cut for me. I said that calories consumed influence the percent body fat. I don't think it's easy to say the percent body fat influenced the calories consumed per day. That might be true in some cases, or maybe it is, maybe it isn't. But we would need to dig deeper into the data just to see. But overall, my initial reaction would be if we consume more calories, then generally I would expect a higher body fat percentage. So something like this. Okay. But there are going to be those people like bodybuilders who actually consume a lot of calories, but their body fat percentage is lower. So it might actually, in reality, do this sort of arc type thing. Okay. Or, fan out. Okay. That would be interesting to investigate. Okay, but either way, the graph that I made ends up being a scatter plot. Okay, when we do bivariate analysis with two quantitative variables, we visualize it in a scatter plot. So we put, the explanatory variable along the horizontal axis, response variable along the vertical axis, and then all the data points we visualize as an intersection on the grid for those two variables, and so we get a scatter plot. And so here's an example about ice cream sales and temperature at noon. Okay. When we talk about a scatter plot, there's typically three descriptions three things we mention in every description. So we mentioned the overall direction, the form or shape of the cloud of points. That's the general name that we use for the cluster or the points in as a group, and then the strength, kind of how tightly they're bound together. So for this example with temperature at noon and ice cream sales, I would say, okay, the direction is as you're going to the right or as you increase temperature, sales are also increasing. Form, it appears to be kind of a line. Like I could see drawing a line through this, so I might say it's a linear relationship, or if there's some other geometry going on, you can mention that it makes an arc, it kind of makes a fan, something like that. Fan would look something more like this. But you can mention all that. And strength, well, it appears that they are all kind of bound together tightly, right? If it was not bound together tightly, we would see something like this pop up. Okay, so kind of data that are all more spread out. Okay, so we'll create a scatter plot in this first Excel example 3.1. And in our first Excel example, example 3.1, this context, you can read more about it in your text. It's example 3.5 from the text. But this NEA stands for non-exercise activity. And so the question that they're investigating is, if you fidget, does that keep you slim? Like, do you actually burn, many calories, or at least not, or do you, lose mass as a result of this fidget or non-exercise activity? And so here you can see kind of the NEA change, that non-exercise activity change in terms of, and it's measured in calories versus the fat gain that corresponds to that. And so to to make a scatter plot, I need to first think, okay, which one's the explanatory variable? So we're thinking that in this context, non-exercise activity influences fat gain. So this is the explanatory variable, and then followed by the response variable. When you're making scatter plots, the explanatory variable must always be in the left-hand column. Otherwise, you might need to, move the columns around for it to work appropriately. Nevertheless, when we make a scatter plot, select the explanatory variable data, then the response variable data, and then go into Insert, Recommended Charts, and then All Charts, and then XY Scatter. Okay, and let's see. You have to be careful with these. I don't want the first one because it's treating that as two separate data sets. And what I do want is something that looks like this one, where one variable is on the horizontal axis and the other one is on the vertical axis. So my horizontal axis, this would be the, NEA, change in calories, and then the vertical axis would be fat gain, and then that's measured in kilograms. Okay, and then I can certainly give it a title. But from here you can see the scatter plot. So great, I created a visualization. And then the next thing I need to do is describe that overall pattern. Okay, so this is a little bit more subjective. So overall direction, I might say it's moving down and to the right. Okay, and form and shape of the cloud, I might say, well, it's looking rather thin and long. Okay. And then finally, what's its strength? And I would say this one appears, at least in comparison to that first example with ice cream sales, this appears to be more spread out. So I would say it's more dispersed, okay, meaning that the strength is actually weaker. And so I just noted that. Down and to the right, thin and long, but rather dispersed, meaning the strength is weak. Okay. And the last thing is this language of striking deviations. And that's just anything that is maybe appears to be very different from the overall cloud of points. And so in your mind, you can think like suspected outliers. We haven't done any formal mathematics to prove it. But for me, this one at like 400, 4, that one, okay, 392 and 3.8, that one, I would say that is a little different from everything else. So I'm just going to make note of that. And this is a little subjective too. So you could list other things. That's what stood out to me. Okay, but that's the idea of how you can make a scatter plot in Excel. Make sure that you have your explanatory variable data on the left side, followed by your response variable data on the right side.